Okay, guys, if you're watching this, it's because I'm probably not feeling that great. I had my second vaccine shot yesterday, which is really exciting, but apparently I didn't make it in today. So, we're going to go talk about Chapter 7.5 Scale Drawings and Models. So, three goals. One, we want to define scale drawing. Two, define scale model. And three, use scale to write and solve proportions. All right, so let's get started. So, let's take a look at what the book has for us. A scale drawing is going to be a proportional two-dimensional drawing of an object. Think about like blueprints. So an architect draws blueprints to make a model of what a house would look like. A scale model is the same idea, except it's going to be a three-dimensional object, right? So like the architect could actually make a 3D model of the house that they're building. So when we talk about scale, the measurements in scale drawings and models are proportional. That's the key understanding here, that this is a proportional relationship to the measurements of the actual object. The scale gives a ratio that compares the measurements of the drawing or model with the actual measurements. So if our scale was 1 inch to 10 miles, the drawing distance would be 1 inch. So you would draw 1 inch on the paper. But in reality, that would be 10 miles in the real world. So I'm going to go through one example problem, and then you're going to do one in your notes. So what's the actual distance, D, between Cadillac and Detroit? So Cadillac and Detroit, they're two cities in Michigan. So this is the state of Michigan. So here's Cadillac, here's Detroit. And they want to know what's the distance here between these two cities. So we have a scale on the map. The scale is located right here. What the scale tells us is that 1 centimeter on the map is equivalent to 50 miles in the real world. And this line here between Cadillac and Detroit, that's about 3.5 centimeters. So we can set up a proportion to solve for the actual distance in the real world. So I can take my map scale, 1 centimeters to 50 miles, and I can input the 3.5 centimeters. That's the distance between Detroit and Cadillac. And the unknown value is how far it is in the real world. So here's my proportion. 1 centimeter is to 50 miles, as 3.5 centimeters is to D. And then, of course, to solve the proportion, we cross multiply. D times 1 is D, and 50 times 3.5 is 175. So what that means is, in the real world, the distance between Cadillac and Detroit is about 175 miles. So on the next slide, what you're going to do, I'm going to get you started here, then you're going to pause the video and solve the problem. You're going to find the actual distance between Saginaw and Marquette, okay? So Saginaw and Marquette, again, two cities in Michigan. So Marquette is up here in kind of like the northwest, and Saginaw is kind of down here in the southeast. So we want to imagine if we drew a line between Marquette and Saginaw, how far would that be on the actual map? And then how far would that be in the actual world? So we're going to estimate that this line between Marquette and Saginaw is about 6 centimeters. So I've set the proportion up for you. So here's the map scale. 1 centimeter is to 50 miles, as 6 centimeters is to n miles. So you're going to add the 6 centimeters on your notes, and then cross multiply and solve for the actual distance between Saginaw and Marquette. So pause the video here, go solve that problem. When you're done, come back and keep playing it. All right, so hopefully that problem went okay for you. Now let's take a look at finding distance in a model. The liquid outer core of Earth is 2,300 kilometers thick. Here's a scale model. The layers of the Earth has a scale of 1 inch to 500 kilometers. So that's the scale used for the model. 1 inch in the model is 500 kilometers in the real world. How thick is the liquid outer core of the model? Well, the liquid outer core of the real Earth, they tell us, is 2,300 kilometers. So again, I'm going to set up a proportion. Kilometers would go in the denominator. And my unknown value is how many inches the real model would be. So you're going to cross multiply. 2300 times 1 is 2300. And 500 times n is 500n. So here you have a one-step multiplication equation. You need to solve for n. So you're going to divide both sides by 500. 2300 divided by 500 is 4.6. And 500n divided by 500 is 1n, or just n. So the model is 4.6 inches thick. So now, let's set you up and you're going to solve for another problem. You're going to do number 2 here, where it says on your own. The mantle of the Earth is 2,900 kilometers thick. So that's in the real world. How thick would the mantle of the model be? So again, we're going to use that scale of the model, which is 1 inch to 500 kilometers. And we know that the thickness of the Earth's mantle in the real world is 2,900 kilometers. So I'm going to put 2,900 down here. And then I'm going to cross multiply and solve. So you're going to pause this video, go to your notes, fill in the 2,900 kilometers in the denominator, and then solve for how many inches thick that would be in the model. When you're done, come on back and keep playing the video. All right, next let's talk about scale factor. Okay, so scale factor is a number, and that's the number that you would multiply to either enlarge or to shrink something in the actual world. So, a scale model of this monument, this is the Sergeant Floyd Monument, looks a lot like the Washington Monument. The model is 10 inches tall. The actual monument is 100 feet tall. How do we find the scale? Again, the scale is just going to be the number that we use to enlarge or to shrink something in the real world. So the model height is 10 inches. The actual height is 100 feet. Well, I have 10 over 100. That can be simplified. They can both be divided by 10. So I can reduce that to 1 inch to 10 feet. Okay? Now, for scale factor, what's really important to understand is that it has to be the same units, the same labels. I have 1 inch to 10 feet. They're not the same units. They're not the same labels. I have inches and feet. They're different. So what I need to do is convert one of them to the other. I don't really want to change inches to feet, because then that would turn into 1/12 over 10. So what I want to do is change feet to inches. So 1 inch can remain the same, and then I just need to determine, well, how many inches are in 10 feet? Well, if there's 12 inches as 1 foot, I would just multiply 10 times 12, and I'd get 120. Now, both of my units are the same. 1 inch to 120 inches. So my scale factor is 1 to 120. So you're going to do number 3 on the next slide. So let me get you set up and get rolling here. So a drawing has a scale of 1 millimeter to 20 centimeters. So let's set that up first. So I'm going to do 1 millimeter to 20 centimeters. I want to know the scale factor. Scale factor, remember, has to have same units. Millimeters and centimeters are not the same unit. So what you're going to want to do is convert them both to millimeters. 1 millimeter is already done for you. You need to determine how many millimeters are in 20 centimeters. So find out how many millimeters are in 1 centimeter, and that's what you would multiply the 20 by. If you don't know how many millimeters are in 1 centimeter, look it up. Pause the video here, solve this problem, and then come back and hit play. Okay, the last problem in the notes, we're going to save this one for Friday because this one's a little bit more complex. So what you're going to do now, if you finished all the problems in the notes, you're going to log into Big Ideas and you're going to complete 7.5. If there are any problems you get stuck on, that's fine. Just skip over them and we'll tackle them on Friday when we are back together in class. Okay, sorry I missed you today, but I'll see you on Friday. Bye, guys.